Hello everyone, welcome back to my YouTube channel. So in this video, we are going to discuss how we can set up a CI/CD pipeline to deploy our application on Azure Kubernetes services using Argo CD. So this is the architecture which we are going to follow. So the very first thing, we are going to set up two Azure DevOps repositories. So the ones repository we are going to use to store our application source code, and another repository we are going to use to store our manifest file. Manifest file could be your plain YAML file, your Helm charts, like whatever it suits best to you, you can use it. So this is a simple demonstration which we are going to see. So I'm going to use a simple YAML file. So let me do for one thing. Let's see both the repositories first. And when you are doing Azure DevOps plus Argo CD, or maybe Jenkins plus Argo CD, or any tool, any combination with Argo CD, it is recommended you always use separate repositories for your application source code and your manifest file. Why? That I'll come to little later. So first thing, we will verify these repositories. Okay, so this is the repositories Python-Flask. So this is simple Python application which we are going to build and push on Azure Container Registries. So when we will deploy this application, we will see simple this message on our browser. So this is kind of simple hello world applications. And another thing we have on this file, requirement.txt file, which is required because when you build any Python based applications, you need dependencies. So those dependencies we will mention in requirement.txt file. So these are the two main file of application source code. Then we have a Dockerfile. So for Dockerfile, we are going to use Python 3.9-slim as a base image. Then we are going to create a app folder. Then we are going to copy our requirement.txt file. Then we are going to install these requirements like dependencies, whatever we have mentioned in requirement.txt file. Then we are going to copy our source code. So in the source code, we have single file app.py, which we are going to copy. And then we are going to expose it to 5000 port. So this is basically 5000 port is a local port. It's not, this port will not use in your Kubernetes services. So if you are building application locally, then you can use this port 5000. And this is the command line argument, like whenever our container will start, which file it will trigger. So it will go and hit this app.py. So this is very simple Docker file which we are going to use. Pipeline.yaml file I will come little later. Let's verify another repositories. So another repositories we have, let me see. Okay, GitOps Repo. So here I have created a folder called K8s, and here I have simple two files. The very first is deployment.yaml file, where basically we want two replicas of our applications, and this is the name of our application, demo-app. We have defined labels because we need to reference this to a service.yaml file, and this is the image which we are going to use. So now why we need two repositories? So the answer is because the very first repos, which is your application source repos, from that particular repos you are going to build your image and push your image to a Docker container. It could be a Docker container registry, but in our case we are going to use Azure container registries. So basically we are going to push our image on Azure container registry. So what we are going to do as part of this file during the pipeline, basically, so we are going to change this particular tag. So tag is something kind of a commit ID basically. So if we are going to make any changes, new build will be triggered, and automatically this particular version, this tag basically it will update. So if you can see, as of now we have 1074. As soon as we will run a build, this particular path will automatically update it, because end of the day we cannot use continuous delivery using Azure DevOps. So in our case, Azure DevOps, we are going to simply use to build and push our Docker image, and we are going to update the tag of our image on this GitOps repo, because in Argo CD we are going to reference this GitOps repositories. So we will come on that part little later. Now let me go back to my architecture. So here what we are going to do, so we are going to build our Docker image and we are going to push to Azure Container Registry. So let me open a pen here. So from Azure pipeline, we are going to building our Docker image and we are pushing to Azure Container Registries. And once the Docker image will be pushed, the next stage basically we are going to update our GitOps repositories with the latest image tag, because in Argo CD this repositories will be referenced and it will automatically shrink and deploy your resources to Kubernetes cluster. So this is very simple architecture which we are going to follow. I hope it's clear. Okay, now let me. Okay, so this is a service.yaml file which I forgot to explain. So this is simple API version, kind is service, metadata is under specification. We are going to use type as a load balancer because we want to access our application from the local system. And this is the selector demo-app, the same label we have defined in deployment.yaml file. So at least service should know where it needs to forward the traffic. And we are going to expose our application on port 80. And target port we have defined here at 5000, which we have mentioned in app.py. Okay, so this is very simple manifest file, but in real time you will have so many YAML file or maybe Helm charts. Now the interesting part is pipeline.yaml file. So let me go to my repositories and let me explain pipeline.yaml file, because that is the heart of CI/CD. So let me check Python-Flask. Okay, so this is our pipeline.yaml file. So here trigger we are going to use main branch because we have a main branch here. So whatever changes we will commit on this main branch, it is going to automatically trigger your pipeline if you have enabled continuous integration in your pipeline. And we have defined two variables here, imageName, this is the name of our image, demo-app, and this is the Azure Container Registry, which is Argo CD 2211. If I will go to my Azure portal, and this is the container registry name Argo CD 2211. Here we are going to push our images. So if you see this particular stage, build and push Docker image, this is very straightforward. So we are going to use a built-in task here. So here we will not able to see. Let me do one thing. Let me open the pipeline itself. I've already set it up this pipeline because at unnecessary it will take a lot of time to set up a complete pipeline. Okay. So here we have declared two stages basically. So the very first stage is build and push Docker image. And another stage we have created here, update GitOps repository. So let's see what we have in first stage. So in stage 1, we are simply going to build and push our Docker image. Docker image on Azure Container Registry. So for that we are using built-in tasks. So if I will go to settings here, so this is the task which we are going to use, container registry. And this is the container registry name. This is the variable which we have created here because we have already defined the variable here, demo-app. If you don't want to specify variable in pipeline.yaml file, you can use library variable as well. And here we are going to use tag build.buildID. So this will be the image tag which we are going to update in our manifest file, deployment.yaml file. And again, this is also a very important part here. So this is the comments I have added here to explain this particular command, basically what this command is going to do. So here what we are going to do, here basically we are going to create a output variable where we will store our image tag so we can use in stage 2. So this is the internal this script _echo, and this is the basically internal command syntax, or we can say a built-in command syntax on Azure DevOps which we can use. So the very first thing, if you see here, this particular part here. So basically this particular part tells Azure DevOps create a pipeline variable with this name and value. So you can see task.set variable, and variable name is image tag, because variable equal to image tag. So this is the variable which we are going to create. And another here you can see is output equal to true. So this basically makes this output variable to available outside the job or outside the stage basically. So suppose if you want if you want to use this particular variable in another job or maybe in another stage, for that you have to define is output equal to true. So your variable will be available to use in any other jobs or in any other stage. And this is the build id. So this is the value which we are going to set for this image tag variable. So this is the very first stage which we are going to use. Simply we are just going to build our Docker image, and we are going to push our image to Azure Container Registries, and we are going to create an output variable to store our image, build ID basically. And if I will come to a next stage, this is update GitOps repos. So here we are just replacing the image tag with the build ID on GitOps repositories. So the stage name is update GitOps, display name is whatever name you want, you can give it, depends on build and push. So once this stage, if you see the name of this stage is build and push. So once this stage is successfully completed, then only this stage 2 will be triggered, because we have specified here condition succeeded. And this is the variable image tag. So if you can see, okay, so image tag we have created here, this variable image tag. So if you can see how we are going to reference it here, dollar bracket open bracket stage dependencies dot, this is the stage name, build and push, and build job dot outputs, and set image tag dot image tag. So this is the variable which we are going to create. So here basically we are getting the image tag value that we have created as part of this particular task. So here we are going to store build id under this particular variable, which is image tag. Second is jobs. So update GitOps jobs, whatever name you want, you can give it here. Similarly for display name. And here we don't need to check out the complete GitOps repositories, or whatever name you are going to give for your manifest repositories. You don't need to check out that particular what is called repository, sorry. So here basically we are going to use a script. So we are going to use inline script. If you want, you can keep this script in your repositories as well, and you can use file path as well. Okay, so the very first thing what we are going to do, we are going to create a variable called git _clone_dir on Azure DevOps agent, and the value is GitOps-local. So this is the environment variable which we are going to create on Azure DevOps agent, where in background this task or this script is going to execute, and the folder name will be GitOps-local, means the value of this variable will be GitOps-local. So whatever code we are going to use or copy or maybe clone, that will be cloned under GitOps-local folder. And another folder, or we can say environment variable we are going to create here is AKS-deployment-path. So this is the path of our deployment.yaml file. So if I will go to my repositories, let me open it another window. Okay, so here we have a folder called K8s, and under this folder we have a deployment.yaml file. So that's what we are going to create a variable here, K8s underscore deployment underscore path equal to this value. Now we are going to configuring the identity. This is required when you commit your changes or when you push your changes. For that you need a user email and user name. So you can give any name, it doesn't matter, but it is required. So here we are going to use clone our Git repository. So this is a very important part here, because and we are going to clone this repositories under GitOps-local folder which we have created. Okay, so now if you can see here in Git URL, this is the variable which we have declared. Here we are going to use https://x. So x is here is a username, and GitOps underscore PAT underscore secret is a variable which we have created. So basically you need to authenticate your GitOps repositories as well. So for that you need a PAT token. So this is the PAT token which we have created. Let me show you how you can create it. So you have to simply go to here, personal access token, and for example in our case we are going to use CI/CD GitOps push. So if I will edit this, we cannot see the password here, but we can see the name here. So this is the token which we are going to use, and we have given a permission here as well. So if I will come here, if you can see under code, read and write, in under build we have defined read and execute. So these are the custom permissions which we have given to this PAT token. So this personal access token is going to use to authenticate your GitOps repositories where you have your manifest file. So this is required, and I have declared this under variables. So here you can see GitOps underscore PAT. This is the variable, and this is the value of this PAT token which we have saved here. And this is our repository URL. So if you see, let me go to repository again. So if I will do a clone, so this is the repository URL. You can see GitOps -repo, and same thing we have mentioned here. But before that we need this username and password to authenticate this our repository. If you want, you can also use Git credentials as well. Like for example, you can generate a Git credentials. So this will also basically generate a PAT token for you. Okay, so this is required for cloning our repositories on ESENT basically, where we are going to do a replace image tag. Okay, so this is the command which we are going to use, git clone, and this is the URL. So we have used a variable $git_URL, and this is the git clone directory which we have defined here, which is GitOps-local. So this code, this repos will be cloned under GitOps-local folder inside your Azure DevOps agent. And here we have defined which branch you want to check out. So we have defined a main branch, because this manifest file also we have under main branch. And this is the full image. So here basically we are using a variables ACR repositories. So this variable we have declared top of the YAML file. So this is the repository URL, sorry, container registry URL, and similarly image name also we have defined here, which is demo app. So these two variables we are going to use here. Okay, where it is, okay, and this is the image tag. So image tag is this one. This is basically build.build id. This is the output variable which we have set it up in stage 1 here basically. Okay, so this is the full image, and this is the basically simple message using the echo command. We are passing like updating deployment file with new image, and this is the very important command which is actually doing a replacement here. So you can see the first sed-i. So sed, oh sorry, so sed stand for stream editor command, and -i basically it's added the file in place, like basically override the file. So for that we use -i, and as pipeline symbol image. So this basically find any line which start with image because if you can see we have used image colon dot dot star. So any line which start with image image things basically it will override it. So if I will go to here, let me go to deployment.yaml file. So you can see the image. So anything it find after the image, it will replace entire thing basically. And this is the full image path which we are going to use. So full image we have covered here, and okay, so okay, where it is, okay, and this is the deployment path. So where is your yaml deployment.yaml file? So this is also we have checked it out here, like basically we have created our environment variable for that. So in short, this is the line which is going to replace your image docker image id, or sorry not id, image tag basically here. So this is the replace pattern, like what this command is going to do. So that's what I have explained in this particular line. What I will do, I will update this entire code on GitHub, and I will share the link in description box. So if you want to do hands-on with your own, you can do that also. So simply we are going to add a local changes, then we are going to commit the changes, and we are going to push those changes to our GitOps repositories. So simple terms, like what we do in our local system, we will download the code, or we will check out the code on local system, we will do some modifications, then we will update it back to any repositories, GitHub, GitLab, whatever you are going to use. So here simply we are just replacing the build ID which is required, because that new tag will have the latest changes as well. So this is the pipeline.yaml file which we are going to use. So now let me do one thing. Let me run this pipeline. So if you see here, let me open this. So for now you can see the build ID here is 1074. So once we will run this pipeline, let's see what ID will come. So new ID here is 1075. So this file will automatically replace with 1075. Let's wait to complete this pipeline. And as of now, we have not set up the Kubernetes cluster and Argo CD, so that part is also remaining. So meantime, this pipeline is going on. Let's quickly go and set up a Azure Kubernetes cluster as well. Here the important thing is, like, we are not using or integrating Kubernetes cluster with Azure DevOps. We are just updating, building our image and pushing our image to Azure Container Registries, and we are just updating our manifest file. And in Argo CD, we are directly referencing our Azure repos with Argo CD. So whatever the latest changes we will push on the GitOps repo, it will automatically deploy to Argo CD. That's why we call this a GitOps pipeline as well. So let's quickly create a Kubernetes cluster here. So I'm not going to explain this thing because I have already covered many times in my previous videos. So let me use cluster name. Okay, rest all the fields I will leave default. Okay, under node pool I will change the image sorry, VM size here, because we don't need this high configuration for this demonstration. So here I will go with A series. Let me choose A2 B2, and number of node counts we need minimum 1 and maximum 2. Let me update this. Okay, so here also I will leave everything default in networking. Let me add my container registry here. This is anyways not required because we are not going to use an Azure container registry here. So let me uncheck it because it is not necessary. And Azure policy, it's fine. I don't want any monitoring, even alert as well. Next, and review and create. So this setup is going to take at least 5 to 10 minutes. So meantime, let's verify our pipeline. Okay, so we can see our CI pipeline is completed. Image tag output, it's okay, completed. Build and push. Okay, so it successfully pushed our Docker image as well. Let's quickly verify it. Let me go to, okay, so in container registries repository, which is demo-app, and here we have a latest build ID which is 1075. Okay, now let's verify here. Let me refresh this. So here we have latest changes which is 1075. We have not made any changes, but once we will set up this Argo CD part, we will make some changes and we will do again, we will build our pipeline. So we will at least verify, okay, how Argo CD is automatically going to pick our changes from the GitOps repository. Okay, so okay, this is also completed and we have also verified the build ID is 1075 here. So let's wait couple of minutes. Once the deployment of AKS cluster will be completed, we will move forward. Okay, so deployment is completed successfully. Now let's connect to this cluster first. So let me open the command prompt. So here I will go to connect and I will use Azure CLI and I will download the cluster credential which is required to connect to the Kubernetes cluster. So let me run it. Okay, let me copy again. So basically it will download cluster config credentials in my local system, which is this location under kubeconfig. So let me run kubectl get ports and let me verify all the ports. So if you can see, we don't have any port with the name of Argo CD, and Argo CD server run inside a Kubernetes clusters. For that there are few steps which we need to follow. So let me clear the screen first and I will go to my GitHub. So here are the steps which I have mentioned here. So the very first thing, we need to create a namespace called Argo CD. It is recommended you have to create a separate namespace for your Argo CD server. So let me copy it, this command. Let me run it. So if I will run kubectl get namespaces, so we have these many default Argo CD and these are the system node spaces. Next thing, we need to install the Argo CD. So for that we will, this is the official command which we are going to use. So this will install a lot of things which is required to run Argo CD server inside a Kubernetes cluster. Okay, so this is completed. Let me verify the ports. kubectl get ports hyphen, we will use a namespace called Argo CD. So here we can see the status of containers, Argo CD application controller. Then we have notification controller, Redis, Repo server, Argo CD servers. But we are interested about this particular part, Argo CD server. So from this, basically, once this pod is up and running, we can access the user interface of Argo CD server. So let's wait a couple of minutes. Once the status of all the pods will be running, we will try to access our Argo CD server. Okay, let me rerun it. Okay, so now we can see the status is up and running, but still we can see a 0 out of 1. Maybe it will take again few seconds. Okay, now it's came up 1 out of 1, which is up and running. So now we need to access the Argo CD server from our local system. So when we install Argo CD using this particular official command, this particular command basically use a cluster IP, which will not provide us an external IP address. So if I will go and check the services, let me clear this. kubectl get sbc. So here we can see, we have to specify namespace, which is Argo CD. So these are the services. If you see Argo CD server, so we have, it is by default is using cluster IP and we don't have any external IP. So we cannot access Argo CD server from our local system. For that we need to change the type here. We have to change it to either node port or load balancer. So for that we are going to use kubectl patch command. So this will update the configuration. So let me check again. So you can see a cluster, here network type is load balancer and the external IP status is pending state. Okay, so now we get the external IP address of our Argo CD server. So let me copy it and open it in our browser. Okay, so this is self-signed certificate official. So this is not a valid certificate. That's why we are getting HTTPS warning here. And by default, username of Argo CD server is admin. And for password, so for password basically, let me check the command. Okay, so the initial password of Argo CD server will be stored under this particular application part. So if I will simply run kubectl get secrets, let me clear the screen first. Okay, let me use namespace Argo CD. So this is the initial admin password. So under this file, basically under this secret, we will have a encrypted password. So we need to use, or we need to basically decrypt the password first. So first we need to identify what password we have inside this file. So for that, what we will do, we will simply output this as a XML file. Okay, it's not copied. Let me copy again. So this is the password, but this is the encrypted password. So if I will use this password here, it will not work. You can see invalid username or password. So what we have to do, we have to decrypt this password first. So I'm not using a Windows, so I'm going to use a PowerShell to decrypt this password. So let me copy this command and let me open the PowerShell. Now this is the value of our password basically. So let me copy it and let me run it here. Okay. Okay, still showing invalid. Okay, let me refresh it. Let me open a notepad as well. Maybe the password which I am copying is not correct, or maybe some spaces is there. Okay, let's verify it. Okay, it looks like correct only. Okay, so there is one thing which I have missed here. So the very first thing what we have to do, let me open it in this window so it will be more clear. Okay, let me copy it again because this is not a correct encrypted password. So let me copy it here and I will go to my command prompt and let me copy this encrypted password first, and I will change the value here. Now let me run it. So this is the correct password. Okay, so this is the user interface for Argo CD server. So now what we have to do, we have to add our Kubernetes cluster on this Argo CD server. So for that we will go to settings and clusters, but here you will not see any options to add Kubernetes cluster. So for that we need to use command line or Azure CLI, whatever preference you want, you can use it. So for that, first we will log into Argo CD server and let me open my command prompt, clear the screen, and here we need to change this IP address. So what is the IP address of our Argo CD server? Let me copy it. Let me put Yash. Now we need to again give a username, so which is admin, and let me copy the password. Okay, so now it's logged in successfully. Let me minimize this. This is also not required. Okay, now we need to add our cluster. So this is the command argo cd cluster add, and this is the cluster name, which is my -AKS cluster, and -- insecure because we don't have a valid HTTPS certificate. So let me run this command. Let me run yes. Okay, so now if I will go to Argo CD and let me refresh this. So now we have added our cluster on Argo CD servers. Next thing, what next you need a repositories which will be automatically sync. So for that we will use repositories connect repo, and here we will use HTTP and HTTPS type git, and you can give any name. So let me give my repo project name, let me use default repository URL. So now let me take a repository URL, let me clone it, and I will copy this command Oh, sorry. Now again we need a credentials to authenticate this particular repositories. So what we will do, we will go to repositories and we will generate a credentials. So you can see the username is sobek.agrawal, but we can give any username here. Let me copy the password. So here let me give username demo, and password I will give password here. Now let me click on connect. So you can see connection status is successfully. Now my Argo CD server is connected to my GitOps repo. Next thing what we have to do, you have to create a new application here. So here you have to define your application name. In our case we will define a Python app. Project name we will use default. Synchronization policies, how you want to synchronize your repositories using Argo CD server. So we want automatic, like whatever changes we will push, as soon as we will make any changes or any commits on our repositories, it will automatically shrink those changes. Self healing as well, this is also required, and rest all the fields I will leave default. So now we need to define source and destination. So source will be our repositories which we have added, and revision is head. So head basically is a commit ID, and path. So let me check the path here. So path we have K8-S. Sorry, a K8S, not hyphen. Now cluster URL we will select from the list, and namespace we will use default. So whatever the resources will be deployed, that will be deployed in default namespace. So let me create this application. So we have just created the application. Now you will see the synchronization. I have not done anything. It is automatically start synchronization. Sorry, it is automatically started shrinking our repositories. So let's wait couple of minutes. The once the status will be healthy or successful, then we will verify it. So you can see we have defined two replicas of our application. So we can see two replicas here, two pod is getting created, but the health is still progressing. So let's wait couple of seconds. Okay, so we can see still it's in progressing. Why? If I will open my pod here and let's verify the events. So we are getting a back of pulling image. Why? Because when we have created a Azure Kubernetes cluster, we have not integrated Azure container registries. So AKS cluster is not able to pull the image from the ACR. So what we need to do now, we need to integrate, or we need to attach Azure container registry to Kubernetes cluster first. So let me do one thing. Let me open a command prompt here. Let me clear the screen and let me use this command. Okay, so resource group is not demo. Let's see if it works. Okay, so it is adding role. So basically, when I was creating Azure Kubernetes services, I completely forgot we need to integrate our Azure Container Registry as well, because end of the day the image will be pulled from the ACR itself. So that's what now we are going to attach our Azure Container Registries with Kubernetes clusters. But like if you are creating fresh Kubernetes cluster, then it is recommended you always integrate your ACR while you are doing setup using Terraform or maybe using Azure portal. So let's wait couple of minutes. Let's see what will be the result. Okay, so we can see this command is completed successfully. So it is attached our Azure Container Registry with AKS clusters. Now let's go and verify the health status. Okay, so now we can see the app health is healthy and both the application pod is up and running. Let me go to this and let's browse our application first. So what we will do, we will go to demo services, and from here we will get a load balancer IP address. Let me copy this and so we are getting a message hello from Azure DevOps plus Argo CD pipeline. So now what we will do, we will make some changes and we will again build our application, and you can see this commit ID is 2AC9345. If I will come to this and check history, so let's see, commit ID here is 2AC93. So this is the commit ID. So it will basically automatically use a latest commit ID if you are using head, but if you want to specify any tag you can do that as well. So what we will do, let me go to my application, and here I will make some changes on this file. So let me remove this and let me add, this is a simple demo of Argo CD. Now let me commit these changes. Okay, let me go to pipeline. So I have not enabled a CI/CD, sorry, continuous integration, that's why it is not triggered. So let me run this pipeline. Let me minimize it again, run. So now if we will see latest commit ID, so that we will see here as of now it's 2AC. Let's wait to complete this pipeline first. If you want, you can add some health status on Azure DevOps as well to verify the health status of your applications. So now build ID is 1076. You can see here now the commit ID has been changed to AC2. It is now 023 something. So let's go to this repository and refresh it. So we have a latest commit which is 0231, and if I will go to deployment.yaml file as well, so here you can see 1076 is a build ID, and same we can here is build ID is 1076. Now let's go to here, go to application, so here we have, okay, it is not shrink yet, so let's wait a few seconds, because you can see a last shrink is 60 minutes ago and it is automatically should be refreshed. So let me refresh this one. You can see it start shrink, and you can see the last shrink is the few seconds ago. We have not done anything. We have simply run our CI pipeline, which build and push our Docker image and uh, update the GitOps repository, and it is automatically deploy the latest changes on our Kubernetes cluster. If I will come to this and refresh it, so this is the message which we have added. This is a simple demo of Argo CD. So that's how basically you can set up a CI part with Azure DevOps and CD part with Argo CD. Similar combination, you can use any CI tools basically. And this is the GitHub repo link, which I will add in description box. And these two folders contain the entire application's code and manifest file as well. So I hope it's clear. In case if you have any doubts, you can definitely ping me on comment box. So that's all for today. See you in next video. Thank you so much.